Hello and welcome to my presentation. I am Mohammad Reza Fanisani and will present our new research paper that is about an incremental prototype selection method using clustering to help process discovery algorithms. The other authors of these papers are Mathilde Boltenhagen and Will van der Aalst. One of the main variants of the process mining field is process discovery that aims to discover a descriptive process model from real events that are recorded usually by information systems. They have different notations to show descriptive process models like BPMN, PetriNet, and process graphs. There are many discovery algorithms proposed in the literature that usually perform perfectly on synthetic event logs. However, when we apply most of these algorithms on real event logs, the discovered process models are usually very complex or sometimes very imprecise. The imprecise process model is a model that lets many behaviors that are not recorded in the event logs also be executed by the model. The main reason for these problems are existence of lots of unique behaviors and the presence of noise in real event logs. Moreover, some approaches are also impractical for large real event logs. The outline of the remaining parts of this presentation is shown here. I first briefly explain the solutions for the mentioned problems. Thereafter, I will explain our proposed method. Afterward, the experiments and the corresponding results will be discussed. And finally, I will conclude the presentation and provide some possible new direction for extending this research. To overcome the mentioned problems, some pre-processing techniques try to reduce the size of the input event log by somehow filtering infrequent behaviors, statistical sampling methods, or using instance selection techniques. In all of these approaches, the original event logs will be reduced to a simpler one, and by applying process discovery algorithm on them, we will have one simpler process model. On the other hand, there are also some techniques like clustering methods that partitioning the original event logs to smaller sublogs, and consequently we will have several simpler process models. However, interpreting all sub-process models could increase complexity. Also, in some applications, a process analyst needs to have one process model that describes the given event log. So our proposed method is placed in the left category. Therefore, we aim to just give a small set of unique behaviors to process discovery algorithms. And to do that, we use a clustering method, and we use an incremental method. Here you can see the schematic view of our proposed method. The input of the method is an event log, and the output is a process model. So first, we propose to cluster traces in the event log. To cluster traces, we use the edit distance method. For example, assume that a trace for a process instance is presented as a word, and we try to cluster a list of words. Therefore, similar traces will be placed in a similar cluster. To cluster, we use k-medoid algorithm. And as we know, a drawback of this method is that we should give the number of the cluster, and we sometimes don't know this number. And but for each cluster, we return the most representative trace or medoid of the cluster and put it into the selected prototype. So selected prototypes is the output of our clustering method. For example, suppose that we have an event log with 19 traces and 10 unique variants. So each trace here could be considered as a word. For example, a D could be a word. Afterward, we choose the method of afterward we give that, for example, we should put them in 3 clusters, and we will have these 3 clusters. So traces with similar control flow information will be placed in the same cluster, and from each sub log we choose one representative trace and put it in the output event log. So we reduce the original event log to a selected prototypes that are only 3 traces. In the next step, the selected prototypes are given to a process discovery algorithms. We recommend to use process discovery algorithms that are always return sound process models, like inductive miner or a split miner. When thereafter, we should analyze the quality of the discovered model, and for this purpose, we use the original events log and the discovered model. There are different measures that could be used in this regard. For example, fitness, precision, and F measure. That is a combination of fitness and precision. After analyzing the quality of model, we try to find traces that are deviated with the process model, that are not replayable by the discovered model. And again, we apply the clustering method on the deviated traces. So again, we add the new prototypes to the previous ones and discover a new process model. If the quality of model is improved according to our measure, we continue to find the deviated traces and do clustering again and again. Otherwise, we return the previous discovered process model. So we iterate until there is an improvement in the quality of discovered process model. So we implement this method in both ProM and RapidProM. The input is an event log and also the number of cluster, the process discovery algorithm, and quality measures. To evaluate the proposed method, we use 6 real event logs that are publicly available. We use 3 process discovery algorithms, and for 2 of them that are inductive miner and split miner, we use different settings. For pre-processing event log, we use 4 different conditions that are using the original events log without any pre-processing, using the proposed method, that is prototype selection, sampling event log, using a statistical sampling, and using instance selection methods. For example, selecting the most frequent variants. Here you can see the average results of fitness, precision, and F measure when we use different pre-processing methods and different process discovery algorithms. So we can see that without using without using a statistical, without using any pre-processing method, that is nothing. We will have very similar results when compared to the case that we use a statistical sampling method. And using our method, that is prototype selection, we usually have a better trade-off between fitness and precision, and consequently we will have a higher F measure. So here you can see the complexity of discovered process models using different pre-processing methods. Here, model size represents the number of places, transition, and arcs in the discovered models, and a higher value indicates that the discovered model is more complex to be understood. The Cardoso measure also indicates the complexity, and higher Cardoso means the process model is more complex. So it is shown that in most cases, the proposed approach can discover a simpler process model using different process discovery algorithms. It is also shown by the experiment using clustering for prototype selection has more advantage compared to more naive approach, selection approach like frequency-based selection methods, or for example, using similarity-based approach. If you are interested in the results of this experiment, please take a look at the results of that is presented in the paper. To conclude, we find that by just using a subset of traces of event log, we are able to discover a simpler process model with a higher F measure. To detect this subset, we propose to use an incremental method using clustering and process model quality measures. We also find some limitation in our work. As we use k-medoid for clustering, we don't know the best number of clusters beforehand, and it may lead to not finding the best subset. The proposed method uses conformance checking to measure the quality of discovered models and deviated traces. Therefore, it is slower than other pre-processing methods. We think that by using conformance checking approximation methods, we are able to improve the performance of the proposed method in this regard. Moreover, it is possible to use different clustering methods and distance metrics instead of edit distance and compare the results with the current results. Thanks again for your attention. If you have any comments or recommendations, please feel free to contact me. Bye.